Hello guys, and welcome to a video I'm making where I'm going to connect differential equations to a slope field. And so one of the things that I want to talk about is how to take a differential equation, which you guys see here as dy over dx equals negative x over y, and I want to be able to create a visual of this actual problem and then relate how we're solving the differential equation through calculus to the slope field that we're going to create down here. So let's go ahead and look at our example. And the first thing we're going to do is actually solve the differential equation, as you guys have been learning in calculus. So we have dy over dx is equal to negative x over y. And so the first thing you guys learn when we're solving the differential equation is to separate the variables. So we're going to get y dy equals negative x dx. So we're basically cross multiplying is really what just happened here. So we want the y's with the dy and the x with the dx. And then the next thing that we're going to do is we're going to now integrate both sides. So I'm going to use color here to kind of help it pop and let you guys know what we're doing. And that's another thing that I do with my classes is just say, what happened with the blue step or the green step. So we're going to start integrating both sides. And so when we do that, we're going to integrate y with respect to y again. So y dy, and we're going to get y squared all over 2, and then we're going to integrate negative x with respect to x. Well, again, it's just a variable, so it's going to be negative x squared over 2, and then we're going to do a plus c. We could have done a plus c over here and a plus c over there, but that ends up just being a c. So when we're learning differential equations, remember we just do the c on the x side. And now we want to get y by itself. We want to get y by itself. So the first thing we're going to do is we're going to multiply everything by 2. Okay, we're going to multiply everything by 2. So we're going to get y squared is equal to negative x squared plus 2c. And again, this 2c is kind of arbitrary because we're just looking at some constant c here. And then if I go ahead and rewrite this one more time, then I'm going to go ahead and move this over. I'm going to get x squared plus y squared is equal to 2c, which basically just means that I've created, if you guys see this, x squared plus y squared is equal to some constant, which in this case here is a circle. So we have looked at the fact that this is going to be a representation of a circle. So that's the solving of the actual differential equation. Now we're going to come back to this point 0.03 here in a second, but what we want to do now is we want to create a slope field based on this differential equation. All right, so we have our little chart down here at the bottom. Now I'm going to go ahead and write down that this dy over dx is equal to negative y over x. Oh, sorry, it's negative x over y. And so what we're going to end up doing here is we're going to look at the sign of our slope as we plug in. So one of the things I think is pretty easy to do here with slope fields is this. When y is 0, so let's go ahead and make it like this. So we're going to go ahead and do that. This top part's going to be the x and this bottom part's going to be the y. So when y is 0, then this is going to be undefined. So we can't do anything with this. And so if we go up here to when y is equal to 0, y equals 0, we're going to have undefined slopes. So we're going to go ahead and just draw undefined slopes. That would not be that. So undefined slopes would be something like this, right? It's a vertical line. So undefined slopes would look like this. So we're going to basically take this and we're going to create a little picture on this based on this slope field. Then if we go 0, if we make x equals 0, well then this whole thing is going to end up being 0, right? All these are going to be 0. So we're going to go ahead and use slope up here to do 0. And so we're just, again, creating a nice little visual that represents this differential equation. And then we're going to tie them together here in a second. What happens when x and y are the same thing? So what happens when x and y are both 1, both are 2, both are 3? You're going to find that they're going to end up being negative 1 slope, right? If we just do a quick plugging and chugging, then if I plug in x for 1, y for 1, I get negative 1 as my slope. If I plug in x equals 2, y equals 2, I get negative 1 as my slope. Again, same thing with this. When x is 3, y is 3, negative 1. What if they change, so if they're both negative 1s, you're still going to get negative 1. If they're both negative 2s, because they're going to cancel out, negative 1s. What if they're the opposite signs? What if one is 1 and the other one's negative 1? So if this is 1 and this is negative 1, you're going to have negative 1. The negative of negative 1 is going to be positive 1. So we can all look at these as this. So up here at the point, and what this, again, what this chart's representing is that if we're looking at the point 1 for y and x for 1, we're going to get -1. So at point 1, 1, we're going to get a slope of -1. So -1 is going to look something, like so. It's going to look just a little bit negative like this. Same thing for this one. This is going to be the same thing, 2, 2, 3, 3, -1, -1, -2, -2, -3, -3. Well, what happens when they are on this side, when the line y equals -x? Well, then we're going to go ahead and do a slope of 1. A slope of 1. And again, the slope values don't have to be absolutely perfect here. Just want a good representation of what's going on. Okay? And now, then we just want to start looking at other points on our graph. So, for example, let's look at the point where x equals 1 and y equals 2, right? So that's going to be a slope of -1/2. So I'm just literally plugging into right here. Well, if I plug in, x equals 1 and y equals 3, I'm going to get -1/3. And so I'm going to go ahead and, type in, instead of being now -1 here, this is going to be a little bit closer to becoming 0, a little bit flatter, and this is going to get even flatter. It's going to be even flatter. And that's exactly what's going to happen on the rest of these pictures. So if I come down here in this, and I do, again, the x is +1 and the y is -1, so they're going to be a mirror image of each other. They're going to be a mirror image of each other. So that's really important for us to recognize as we're doing these visuals of this. As I'm moving down, I'm going to get closer and closer to it becoming the slope being 0. And so that's going to eventually happen as we move along with this. So I'm going to go ahead and start plugging in values. All right, going to go ahead and plug in values here, and we're going to start writing these slopes up for us, and then I'll come back with this video. So I went ahead and looked at plugging in all of these things, and the good thing about this is that you will see a pattern here. So when one's positive and one's negative, then this is going to make all the values positive. Same thing down here, when one's positive, one's negative, you're going to have positive values, because again, this is going to change the sign. When they're both either positive or they're both negative, then you're going to actually have a negative value, because again, this will be positive and this will be negative. So this looks very crazy. So what I'm going to do here is actually just move all this away for a second. So remember, our differential equation was x squared plus y squared equals c. And so if I were to go ahead and move this out of the way, for a second, you guys can see that we've now created what looks like a circle. And so I went ahead and got rid of all the background for a second, just to show you guys a couple things here. So I used the chart, which again looks kind of crazy without the actual. So I used the chart to organize my information. And again, I plugged in all my values for x and y here to get the values that we see here. I used the slopes, again, like -1/3 would look something like this, a negative slope value, a little small value of this, to get the circle. The last thing we're going to talk about here is now how these two relate to each other. So this was a algebraic way of representing what you guys now can see in this picture. And so I used the point, if you guys remember from the very beginning, I wanted to look at the point 0, 3. So I'm going to go over here, again, just think about this as the coordinate plane. Here's 0, 3. And the slope field, basically, I always tell this is kind of like wind. It's kind of give you a behavior of how a graph is supposed to go. So this says I'm going to go this way, and this is okay, and I'm going to start going a little bit steeper, right? It's going to get steeper here. It's going to get steeper, and then all of a sudden it said, okay, we have to go straight down. So we're going to go straight down, and then it's going to go steeper. Now we're going to go a little bit this direction, right? It's just this, the slope field is just kind of telling us to kind of go which way we want to go. And now remember, we're going to go towards 0. And you guys are hopefully starting to see what our pattern is here. So slope field, again, it doesn't have to be exactly perfect. Just telling us, a behavior of what our graph is. The behavior of our graph. And so there we go. We now have a circle. So we have a circle with a radius of 3. So in this case right here, we have a radius of 3. So this equation of this circle is going to be x squared plus y squared is equal to 9. And what's beautiful about this, ladies and gentlemen, is the fact that if we were to plug back into our differential equation, right down here, at this, and we plug in 0 for x, we plug in 3 for y, we're going to get that c, not c squared, c is going to be equal to 9. And that's exactly where we can now rewrite this as x squared plus y squared is equal to 9. And this differential equation with this given point is now equal to the graph that we created based on our slope field. So this is a good visual for us to use to basically show the relationship between the slope field, and which is a visual representation, and the differential equation. So I hope that helps, and yeah, so I will see you guys in the next video.